Hey guys, sorry I can't be there today. Got to stay at home with my youngest son, Colby. Not feeling great. So I decided we can still move forward because the stuff we did today, playing bingo, identifying the type of factoring before you factor, is all going to play into what we're doing today, which is factoring completely. So before we get to the factoring completely part, the idea of what we're doing is breaking a polynomial into prime polynomials, kind of like we would do when we can break numbers into prime factors. So, for instance, if I have 30, I can factor 30 into 2 times 15. Those are both factors of 30. That is factored. But they're not all prime numbers. So 2 is a prime number, so that would continue to be 2. 15 can be broken down to 3 and 5. Now, the numbers 2, 3, and 5 are prime numbers, so that is completely factored down to prime numbers. We're going to take that same concept. I'm going to take that same concept when I have an expression now, such as 3 x to the third minus 27x. So first thing I want to always look for is the GCF. Does this have a GCF? Yes, they both have the number 3 in common, and they both have the variable x in common. So I'm going to factor that out using GCF. I like to think what times 3x would give me 3x cubed, and that's x squared. What times 3x would give me 27x, and that is just 9. Now that I factored once, and here's where you want to be good at identifying polynomials that can be factored. I'm looking over my factors, and 3x by itself cannot be factored again. It's a monomial. But I noticed that x squared minus 9 fits all the requirements for difference of two squares. So from there, I can break x squared minus 9 to x plus 3 and x minus 3. Am I done? Well, let's check it out. 3x, prime factor. X plus 3, no GCF, not a trinomial, definitely not difference of two squares. Same thing with x minus 3. So right there, all my factors are prime polynomials, so I am done. Okay? I want to do this one right here, 6x cubed plus 60x squared plus 150x. Again, the first thing I'm going to look for is a GCF. That's always going to make your life easier. And you'll notice that there are going to be some on the worksheet today that looks like a dots, but if you factor by using dots first, it's going to jam you up as you try to keep on factoring. So GCF first, look at this one. What do they have all in common? Well, definitely an x. 6 goes into 60. 6 also goes into 150. So 6x in common. Let's see what's left. We have an x squared plus 10x plus 25. Trinomial with that a term, a value of 1. So that fits into that pattern that we've been using to factor a trinomial. So the plus sign next to the 25 indicates they're going to be the same sign, my factors. That will have the same sign. Since it's a plus 10 as the middle term, that both those signs are going to be positive. What are the factors of 25 that add up to 10? Well, we can see it's 5 and 5. And since I want to make this look cool, I'm going to write this as 6x times the quantity x plus 5 squared. Okay. A few important things I want you to make sure. The common mistake, when you have that GCF, you first have that GCF, that needs to stay with the final factors the whole time. So don't, just because you factor out a GCF, it's not going anywhere. It's still part of the expression. Just as if I was going to factor 40, right? If I factored 40, I could factor 40 into 2 times 20, then break 20 to 2 times 10. And 10 could be 2 times 5, right? If any other way I lost any one of these 2's, that final expression would not be equal to 40, and I would be changing the value of my original expression. All right. So good luck. Have fun factoring completely, and I look forward for you to show me what you can do on Monday.